recently made a 5% strength chemical mixture to spray his grapevines. The strength of the spray should be 8%. He then adds pure chemical until the strength reach 8%, by which time the volume is 350 liters. How much pure chemical did he have to add? Okay, after read this, it's like a chemistry class. Okay, we're trying to do some experiment. Can you tell me in the mixture, except the pure chemical, what else do we have? Do you know that? Well, the strength, what mean by strength 5%? 5% of the chemical. So if I have 100 liters, how many liters of chemical do we have? So what's the rest of 95? Water. Okay, it's water. So like say we dilute it, like we make it, like add water into that, make it not that strong. Okay, what's in the pure chemical? Nothing except chemical. So what's the strength for the pure chemical? 100%. Pure chemical, 100%. So if you have X liters of the pure chemical, well, you will have X liters of the chemical, right? The volume is X liters, the chemical will be X liters. Okay. This is the 5% strength chemical. Okay, I don't know how much we have. That's the 5% one. I add pure chemical into that. What has been increased? What increased? The strength, yes. Anything else? The amount of chemical, yes. And the volume in total increased as well. Okay, so chemical increased and the volume increased as well. How do we calculate the strength of a chemical, like the mixture? Like for example, I have some mixture. How do we calculate the strength of the mixture? How do we? A general equation, like, well, strength basically means concentration, right? What's the concentration of the chemical? How do you calculate concentration? Yeah, fraction, yes. Like, what's the numerator? What's the denominator? Well, I mean, if we got volume equals to X liters, and we have some Y of the chemical, Y liters of the chemical. How Y over X, which is the volume of chemical, right? Over the total volume, right? It's not over the volume of the water, it's the volume of the total mixture, right? That's the concentration. That's how we calculate the concentration. Now let's have a think. We don't know a lot of things. What do we know? Let's think about what do we know. We have some mixture before. Okay, add pure chemical. We end up with a new chemical, but definitely increased. Well, I say the volume is here before, and definitely increase in volume. So the strength of that is 5%. The strength of that is 8%. What else we know? Volume of that is 350 liters. Okay, what do we have in this bottle? Like, we have two things. What are they? Chemical and water. And in the pure chemical, we only have chemical, right? What else we have here? Pure chemical and water. Plus water, right? Okay. So what we don't know is the volume of the original and the volume what we add in, right? That's the two things we don't know. We don't know what we originally have. I don't know how much chemical I have added. Yeah? So I'll say that's X liters originally, and that's Y liters I have added. Okay. Can you tell me how much pure chemical here? How many liters pure chemical here in this bottle? Sorry, what's that? We have X liter of the total mixture, and the strength is 5%. X still, yeah, like you're on the right track. So it's 5% times X basically. Okay, not like that. Let's not make it complex to say divide by 20. That's 5% of the total volume is the pure chemical, right? Then how much pure chemical here in the second bottle? 8% is the percentage, like how many the volume. 5% X plus Y is the pure chemical will be in the second bottle, right? Because in the first bottle we have 5% of the original volume plus the Y liters we have. That's the total chemical we should have there. Alright. And what else we can have? Is there any other information? What plus what should give you 350? What plus what should give you 350? How do you get the total volume in the second bottle? X plus Y, right? The original amount plus the amount you add, that gives you 350. And just look at this bottle, 350 liters and the strength of 8%. How many liters of pure chemical you have? Like 350 liters, you know, right? It's a strength of 8%. What's the pure chemical in it? How do you calculate that? Well, it's right, but why we can't say 350 times 8%? That's the formula, right? That's the formula. Well, do not simplify it in your head. Like, tell me what it means. Like, let everyone know that. So 350 times 8% is the chemical in this bottle, right? So, well, that is 3.5 times 8. So 28 liters. Yeah, 28 liters. Okay, 28 liters equals to what? Find what we have here. See what we have. Like, we're trying to find equations. That's right. 5% X plus Y is the pure chemical, and that is 28 liters. That's the two equation we can find. Okay, that's the two equation we can find. Well, 5% now I can say that's 1 over 20, so that's 5%. Make it a little bit easier to see. I have set up a simultaneous equation for X and Y. First is the volume, okay, the volume of the total mixture, and the second is the volume of the pure chemical. I can set up two equations for that, and I can solve for it. Yeah, I can solve for it. Try to think again, okay? Well, I'm not really interested in the solving bit, okay? You can solve for that, but I'm more interested in how we can set up the equation, what the thinking needs to be. This diagram shows you what's happened before, in middle, and after. The two things we think about is the pure chemical and water. I don't really care about how much water we have, but we care about more what the 5% means, what the 8% means, what the 350 means, and how you can set up a relationship between those values. Have a think, anything you can't get? Where do we get the 28 liters? Because the final product is something we know already. We know there's a final product with 350 liters with 8% of the strength. So I can calculate the amount of chemicals it has in that solution. But also we need to know the pure chemical come from two places. One is from the original bottle and the other is the pure chemical. It comes from two places. So those two chemicals add together should give you the 28 liters. Okay, and the volume we add together should give you 350. And I can, I'll tell you how to use calculator. That's a good time to use calculator because I'm getting lazy to solve for it. No space. Well, elimination or substitution if asked you to solve by hand. Elimination by subtract the two equations directly. But how do you use the calculator? Okay. Menu 3 and 1 is solve. Okay, algebra and solve. We call the solve function. What I'm trying to solve is simultaneous equation. I want to solve two equations. So what I will do is a button next to 9. Click on that. And there's a 2 and there's a 3. We select the two simultaneous equation. And what I have is x plus y equals to 350. And the second equation is 1 over 20 move it, times x plus y equals to 350 times 0.08, which is the 8%. And okay, after we type all the equation in, move the editing bar to the right hand side, press comma x and comma y because I'm trying to solve for x and trying to solve for y. Comma x and comma y. Press enter. That's what you have. Okay, it's not exact value, it's like in decimals. Okay, it's in decimals. How about if we want to find exact? Remember I've talked about that this is in the auto mode. My calculator is in the auto mode. Because you put decimals here, then it tends to give you decimals in your final answer. But if I can copy this down here, I make the 0.08 become 8 over 100. I don't put decimals, I put fractions, 8 over 100. Let's see the answer. Then that will give me exact values. Can you see I haven't done anything? It's just what you have entered, what you get out. You enter decimals, that will give you decimals, which is infinite many decimals. It's not a integer or like fraction. So, but like when I put 0.08 in the fraction form, then it will give me the exact value. That's the exact value for x and for y. Okay, for x and for y. That's something you must learn for calculator. Okay, you must learn for calculator. Because start of year 11, you're not going to be taught calculator. You will directly be asked to use it. So that's something you need to know. Okay, that's something you need to know.
Oh yes. You're trying all and very cool.